Hello, so today I'd be solving Leetcode 1818. I thought it'd be fun to do it live, so let me read this and then I'll come back to you when coding. So you're given two positive integer arrays, nums1 and nums2, with of length 10. The absolute sum difference of arrays nums1 and nums2 is defined as the sum of the difference for each element. Okay, you can replace at most one element of nums1 at most one element of nums1 with any other element in nums1 to minimize the absolute difference, sum difference. What does that mean? You can replace at most one element of nums1 with any other element nums1 okay, so you just copy, I guess. Then return the minimum absolute sum difference after replacing it at most one element in the array nums1. The answer may be large, so return mod 10 to the power of 9. So can I ask what the constraints are? Wait, why am I talking like this, bro? Okay, so it's this. All right. So for this example, let's see. Replace the second element with the first. Okay, 115. Um, Replace the second element with the third. What? Oh, yeah, okay. Or replace. Both will yield the absolute sum difference. Oh shit, I forgot to start the timer. Okay. Um. We can obviously like brute force this. Um. For example, in the sense that um for this, we can try out we can make this 4, we can make this 6 or 8 or 10. And for this, we can do the same thing. Okay, yes, you can do that. Uh, but that's pretty slow, right? So we gotta make something that will actually work. Um, so minimum absolute difference. So that just means that we gotta get as close as possible to nums2. So that just means that wait. Oh, so you can duplicate it. I don't know how this is hard. I'm thinking like I'm thinking we can do like a binary search. Since these are our options, we can check each element. So, okay, here's what I think. First, you gotta sort 175. Um, so after sorting it like that, okay, then in our nums, yeah, okay, in our nums, what the heck? Okay, 157. So for 2, clearly number 1 is better. Pretty much solved this already, but it's kind of hard like talking as I'm solving this. I don't usually like talk, so um, and if so, This is our nums2. You can obviously do something like here. This needs to be a 1, obviously. And if you do a 1, then then you just get the absolute difference in everything, the prefix and that's really about it. And then for this 3, clearly number 5 is no 1 or 5 is the closest. So yeah, you just pick one. Um, so for 5 is for 5 is closest. So you can do 1, 5, 5. Oh wait, it's this. If you don't, okay, yep. Let's just code this up. I think this will be clear if you code this up. So we can do sorted nums equals sorted nums. This is our sorted nums. What else do we want? Well, we can also get the length of this, and we can get the absolute difference without like any changes, because we can use that to optimize stuff. So like we can do um, min diff would be that would be the sum of uh, absolute nums1 of I minus nums2 of for I in range n. We can print this out to see. I just want to see like what the heck. What does that mean, bro? Oh, is it this? Okay, so yeah, okay, it's 5. Okay, makes sense. Because 2 minus 1, 4 plus 1, okay, it's 5. So yeah. Then we can easily loop here. Loop like nums2. And we actually get 2 options. We don't change, we change. Because it says at most 1. Alright. If we don't change, then okay, the res is this. If we don't change anything. However, if we change it, if we change, let's see, if we change nums1 to something, we gotta change it to want. We want this. Let's call this index. Why not? So we basically want the closest element to number 2. And we gotta search in nums1. Okay, we gotta get the closest number to that. How do we do that? Binary search. So we can define this. That's our bonds for the binary search. M equals. So if Okay, if nums no, if nums1 sorted nums1 of m is greater than or equal to nums nums2 of basically want, we just decrement it, else we can just increment it. So this will give you, m is now supposed to give you the minimum element, or the closest element to that. So once we have the closest element in sorted nums, we can just change it. How do we change it though? We can change it by, so we get, you know what, let's see this first. Let's see what's want and what's no. Yeah, okay, okay, so for 2 closest 1, for 3 closest 1. Oh wait, no, this is supposed to be L, because not M. For 2, number 2 closest is 5. The fudge. Okay. Want nums2 index. Wait a minute. Do, 0 and -1. You want this? 157. 1575 sorted nums m. Let's just debug this first. Print. Okay. 5, 2, 1, 2. Wait, what is L? I think we're supposed to do R. One five seven. Hold on, I'm tripping here. Damn. So 157, correct? So we want two. We want two. Then the closest element for some reason is this 5. But it's supposed to be 1. If you have 2, closest is 1. Oh, it's actually the, wait, no, no. This binary search is actually like the second biggest or equal to. Um, yeah, it's actually the second biggest. Okay. So closest would be um, the closest is L if L equals 0, else okay, closest equals none, if L equals 0, wait, closest equals L if L is greater than 0 and nums L minus nums L minus 1 is smaller than minus want. Okay, so basically what this is saying is that um, we're checking the previous element and which one's greater or which one's closer. If L minus 1 is closer, then we want that instead. Then just subtract 1 because that's our closest. So closest to want is sorted nums closest. Closest to number 2 is 1. Closest to number 3 is 5. Makes sense. Okay. Closest to 2. Yep. And then what we can do now is we can just easily mathematically calculate this shit. First of all, you can't curse in an interview. Um, so we can probably do something like, okay, so first we need to um, temp equals min diff minus this right here, nums1 of I minus nums2 of I. We're just getting rid of it. And then we can do temp plus equals absolute nums want minus closest sorted nums closest. Then we can do res equals min res temp. Then we can just return res. What is this? Oh, index. And that's really about it, I think. 21. Replace the first element with the second element. Is sorted nums closest. I don't get this. Oh, forgot to do abs. The heck. We're just getting rid of this. Okay, and that's really about it. Wrong answer. Oh, because I didn't mod it. Bruh. Don't forget to mod, guys. Alright, there you go. I wonder what the rating is for this problem. 1818. Oh, it's pretty high. Oh my god. Let's go. Q3. Alright, thanks for watching, guys. See ya.